Hello, good evening, my lovely 11th standard warriors. Welcome to the second session of Newton's laws of motion. Last lecture, we have spoken about the three laws. Today, we will talk about strings, tension, the different forces, how to use these forces in free body diagram, and we will also talk about pulleys. So all these forces, all these dynamics around us are easily explained by Newton's laws. In fact, they are the foundation of dynamics. So let's get going, guys, to solve the pulley problems, inclined problems, all the forces and the free body diagram, a related theory and the application, how to draw the FBDs, how to use the FBDs. All of this will be covered in today's class. So welcome aboard. Hi Priyadarshini, hi Riya, hello Suchi, hi Ankit, hello Kalyani, hello Lakshmi Narasimhan, what a name. Hello Meghna, hello Vidya, hi PY, hello Riya, hello Amul, Sudipta, welcome, Arvindan, hello Bugata. Good evening, guys. I'm very good, thank you very much. And before we go ahead, let me quickly introduce myself. I am Shreyas. I'm the physics master teacher. I'm also the HOD of physics for the JEE division, and I have been teaching for more than 10 years. And I used to work in software before joining teaching. So I entered into teaching. I started loving it. I produced a lot of results, and many of my students got 2-digit All India ranks. That's when I took up teaching as my full-time profession, and I have been loving it since then. And trust me, nothing amazes me more than teaching you guys by producing amazing results and spread this joy of learning. And that's what I'm here for, and I will continue to do so. Thank you very much for being here. And you are right now attending the Nurture series. And so what is Nurture series? Nurture series is a long-term batch for the 11th standard kids. We started a couple of months back. We have completed vectors, basic maths, units and dimensions, 1D, 2D, projectile motion, relative motion, and now we are in Newton's laws of motion. This is lecture number 2. And before we begin, to show us your love and support, you know what to do, guys. Go ahead, smash the like button, and if you're new to the channel, go ahead, hit the subscribe button right now. And here is the next thing that I would like to tell you. In case you missed the first class, please watch the replay. It's very important. Remember, all my classes are at 7:30 p.m. in the evening, unless and until there is some special change or due to some unforeseen circumstances or there is some special event, I might have to change the timings. But usually you will find me over here at 7:30. So that's how it is. Next week, we will continue this chapter. We will proceed ahead, and we are going to slowly move towards circular motion as well. Okay, and then friction also is going to come. Okay, so let's do a quick recap, guys. Thank you, Kalani, for liking it. Hello, Khardi. Thank you so much. Hi, Payal. Hello, Lalita. Hello, Guru. I am very good. Thank you very much. Hi, Zaid. Hello, Manvita. Welcome aboard. Hi, Arul. Hi, Sambhav. Welcome aboard. Okay, so your name is Govindan. Fine. Govindan is much smaller and cuter than that big name. Okay. I got scared looking at the name. So Pooja, you are a 2022 aspirant. Will I finish the syllabus before it? Yes. The 11th standard syllabus, tentatively, I'm expected to complete it by November or December. So remember, your board examinations, your CBSE has divided it into terms. In fact, before your term 1, I would have completed your entire 11th standard syllabus on this channel. So that's the beauty of it. So guys, stay tuned. 12th standard syllabus will be over much before that. Okay. Hi Daksh, I'm very good. Hi Hiba. Hi Praneeth. Quickly recapping whatever we have studied before. Yes, Riya, strategy sessions also coming in soon. Next week. Hold on. Just hold on. 11th standard strategy sessions, 12th standard also coming in. We have spoken about system last lecture. This was quick recap. Now what is a system? System is nothing but it's a collection of bodies. So if there are multiple bodies in there, okay, so a collection of bodies is called as a system. It's your choice. Nobody can tell you, you have to choose this. Choice of the system will ease out the problem or might make it look complicated. And there are internal forces and external forces. So the forces acting on the object they are called as the external forces, and that's what matters. Internal forces will not affect anything. So the forces within the system should not be considered. Also choose a reference frame. Okay, so X, Y, origin, or you can choose the XY axis like this, depending on how the surfaces are, depending on how the system is, depending on how the situation is. So depending on all of these factors, choose your suitable reference frame, and whatever forces are there, try to split it into components Fx, Fy, okay, accordingly, so that once you have components, remember, you know, when you show all the forces like normal, gravity, weight, tension, etc., etc. So when you resolve all these forces like these, it becomes easy to solve, because the forces in the x-axis will be mass into acceleration in the x-axis, and the forces in the y-axis will be mass into acceleration of the y-axis, on the y-axis. So this is the total force on the LHS. On the RHS, you have the components of the accelerations accordingly. Remember, do not forget to show the acceleration as well, so that you get an idea of where the object is moving, which forces should be considered, which forces will affect the acceleration, so you get an idea. So that's why show the acceleration. I hope you remember this, guys. So this is very, very important. Okay, very good. Very good, Ankit. If you are reaching Erodo problem, that's very good. By the way, for 12th standard students, I'll be coming up with a special micro course very soon, within a month or two. Once my syllabus is about to be over, trust me on this, I'm going to come up with a special course. For now, just hold on. Okay, we have spoken about normal, weight, spring and tension. All the forces are in this slide. This is quick recap. Remember, weight is nothing but force of gravity, and that is nothing but mass into g. That was the weight. It's expressed in Newton. It's always directed towards the center or vertically down. Then you have the normal force. Normal means it is perpendicular. So this is like the surface. So it's always perpendicular to the surface. This is nothing but the contact force. So whenever two surfaces are in contact, if you draw those surfaces and draw a perpendicular, normal will act perpendicular to it. Similarly, we have talked about the tension force. Is the force of the pull in a string, okay, in a string or a rod or a rope or anything which is thin and long. So it experiences tension force due to the stretching of the bonds of the molecules inside that string. And lastly, we have seen spring force, and remember, the spring force was proportional to x, and that constant of proportionality was k. And what was k? It was the spring constant, which is in Newton per meter. Depending on which spring you are using, the k will change. If the k is large, the spring is very difficult to, elongate or compress. If it is small, it's a very soft or a mild spring. So quick revision, because we are going to use all of this in today's session, guys. Now, before we go ahead, let me also congratulate all the 10th to 11th moving students and all the 10th standard students who have cleared the NTSE examination, and more than 100 students have cleared NTSE examination from Vedantu alone, and it's a proud moment for all of us, and congratulations. And who said घर बैठे rank नहीं निकल सकता? Who says you cannot get ranks from sitting at home? These students have proved that sitting at home through online education, you can get amazing results, and we are giving you the Vedantu Improvement Promise, which is one of its kind promise which no other institute is giving, and that is, when you are in Vedantu, we guarantee you success, and if you do not improve, then the money is returned back. So that's VIP. So you should definitely consider checking out the link which is there in the description box for the long-term batches which are starting 9th of August, and these courses are in English, and there are Hindi batches also available depending on your choice of your mode of communication, what medium do you want it in. And there are different versions which you can definitely check it out, because the prices are very cheap. There are hardly around 2,700 rupees approx per month. When you use my coupon code SHHPRO, when you get 10% off. So that's the beauty of our pro subscription, which has the long-term batches and everything that you can think of. Now let's also start drawing the free body diagram. Thank you, Zaid. V for VIP, V for Vedantu, V for what else? Come on, please tell me what else. You should make some nice cool slogans. V for warriors, but no. Warriors is W, but I like it. Like putting a V and warriors. That's also nice. Hi, Kanishma. I'm very good, Chiranjeevi Sujay. V for Shreyas sir. V for van. Alright, let's get going, guys. Draw everybody for the following diagram. Now, trust me, do not think this is a simple problem, because you'll realize what kind of silly mistakes can occur even in this kind of question. Yes, trust me on this. There are a lot of mistakes that one can do. Now, free body diagram means I have to free that body. Okay, so the body which I'm interested in is that mass. Okay, so that is that mass. What are the forces acting on it? Obviously, it will have its own weight. V will have its own weight. Yes, V for victory, V for, yeah, thank you. Vanquishing doubts for lives. Thank you guys for nice slogans out there. Okay, so weight will be downwards, and that weight will be M into G. That's the magnitude. Earth will pull it down. Because it is resting on the surface, hence there must be a normal force like this. Now comes the beautiful question. Is this object at rest? Yes, because it is just kept on it. So basically the acceleration is 0. If acceleration is 0, that means the net force must be 0 by Newton's first law. Hence, can I not say, therefore, since acceleration is 0, normal force in magnitude should be equal to the magnitude of the weight, and hence N will be equal to mg. Correcto. Now, Ariman, I have given the timings probably in my KVPY lecture. You can just ping me on Instagram or leave a comment after the session ends. I'll definitely ping you. I know you have commented. I'll reply to those comments after the session. Okay. Now is the interesting thing. If I call this force, let's say action, this weight, if I call this action, who is the reaction? Come on, quickly answer in the chat box. Who is going to answer this? Let's see. If weight is the action, who is the reaction? Come on, quickly let me know in the chat box. Is normal the reaction or something else is the reaction? Come on, Newton's third law. Every force, if we call it as an action, there is a reaction force which is equal and opposite. They do not cancel out each other. Okay, surface, normal upwards. No guys, it's none of them. In fact, no. Who is applying this weight? Think about it. Who is applying this weight? Earth on block, correct? Earth on the block. So the reaction will be on the earth by the block. So if one were to draw the free body diagram of the earth, this is earth. Hence, there will be equal and opposite force like this, and this would be called the reaction, because this will be by, this was by the earth on the block, this will be by the block on the earth. This is where people make a mistake. So this is the reaction. Is that clear? Yes. So this should be equal, opposite. So just change the words. By earth on block, so by block on earth. Just change the words, that's it, you will get the answer. Similarly, if I call this normal as the action, where is the reaction? That's my question. So first thing, who is applying this force on whom? See, this normal is being applied by the ground, that is the earth. So by the ground on the block. So the normal reaction by the block on the ground. That means on the earth's surface there will be a normal like this, and that would be the reaction of that normal. So reaction, this will be, by the block on the ground. That's how this works. Interesting. Everybody understood this? How action reaction pairs work? So this is what happens. So Hari, if the normal force is 0 bacha, then the surfaces are not in contact. They are not touching each other. but we know that the surfaces are touching each other over here. So hence the normal force is there. I hope this is fine. Cool. Let's get going. Hi Shiva Kumar. Let's see how many of you can get the next part. And yes, that's the first question. Now there is a block over a block, and this is going to be very, very interesting, guys. Let's see how many of you can do this. Beautiful question. There is a block over a block, and the question is to draw the free body diagram. So what we are going to do is we are going to separate out those blocks and see what happens. Observe this. First, the smaller block on the top, small m. Then the larger block, let's say capital M. Let's draw the free body diagram quickly. On small m, there will be obviously a weight. The weight will be nothing but m1g. Correct? Weight will be downwards. Small m is resting on big M. So do you see surfaces are in contact? There are two surfaces in contact. So there will be a normal force, or else small m will fall down. So there will be a normal force from the common surface. I will call it N1. Alright. Now understand who is applying this N1. N1 is being applied by capital M on small m. By capital M on small m. So by third law of Newton, there should be a reaction on capital M. So that will be by small m on capital M. Hence, there should be a reaction shown like this. This is N1. I know a lot of people do this. They show M1G on M. They show M1G on capital M. Guys, weight is not acting on capital M. I mean, the weight of small m is not acting on capital M. That is wrong. It is transmitted. It is given via this normal to capital M. Yes, numerically, normal's value is m1g, or rather small mg, whatever it is. Okay, this is small mg, no doubt about it. It is small mg. But weight is not acting on capital M. Weight of small m is not directly acting, it is indirectly acting via the normal. There is a separate weight of capital M, that is capital Mg acting on it. This is the actual weight of that mass. Understand, small m's mass is indirectly going via the normal. There is one more force which is missing, and that force you can see is over here. Two surfaces are in contact, right? So if two surfaces are in contact, there should be a normal, and hence there will be one more normal from here like this. This is the normal by the ground on capital M. So if you had to draw the reaction of it, well, you would show like this. This will be N2. So this will be action, this will be reaction on the ground by capital M. That's how it is. Yes, FBD also means now we have free body diagram, freeing the bodies. So separating out the systems. Okay, is it buffering? I'm not sure. Just let me check internet connections in my router. 1 second. It's fine, guys. I mean, the router lights are blinking fine. It's fine. It's fine. Yeah, it's fine. Don't worry. It's fine. Okay. Now, if everybody has understood till here, if you look at this diagram, one more thing will be obvious, because the acceleration is 0. Everything was at rest. So all the forces should cancel each other. So downward normal plus downward weight should be equal to the upward normal, upward force. So therefore, N2 will be N1 plus mg. N1 is small mg, so it will be small mg plus capital Mg. So it will be small m plus capital M into g. That's what you will get. That's the normal from below. I'm just showing you how to find values, how to draw free body diagrams, how to balance the forces. That's what you should learn. Now, there is one more interesting thing that I would like to tell you. Here, we took the blocks separately. Correct? We took the blocks separately. If somebody decided to take both the blocks as a system, then the force between the blocks, small m and capital M, what is the force between the blocks? That's N1. This N1 will become internal force. So N1 will become internal force. That's very, very important to note. The only external forces will be the total weight, and the total weight will be M plus M, that's the total mass, into G, and there will be a normal from here, and that's obviously N2, and from this system also I will get N2 is equal to M plus small m into G. The answer will be the same no matter what system you choose. It's up to you how you want to solve it. Okay, here I have taken the two systems separately, here I have taken it together. Now you'll be like, sir, how do I know which one to take? Simple. If this normal was asked, most likely I will not bother about this internal force. I will take both of them as a system. But if a question says find the force between these two blocks, that means I cannot take the whole thing as a system. So I will separate them out so that the normal becomes the external force when I choose the individual blocks. So I'm making it zabardasti, forcefully external by breaking the system. Is that understood? It's not about easy or difficult, Navya. It's about what is asked and how do you want to approach it. You should know all the methods. Yes, I know that is easy for calculating N2, but if N1 was asked, you have no other choice but to break it. Okay, let's get going to the next question coming up on your screen. So I've just separated it out and did it. Let's do this. Glad guys, you guys are understanding this. Very good Zahid, very good Meghna, very good Deepa. Okay Navya, all right Riya. Alright, and guys, if you're loving this session, do not forget to smash the like button down there in case you have forgotten. And if you're new to our English channel, please hit the subscribe button so that you do not miss any of our classes. Now, here's the next question. There is a spring, there is a mass, and it is attached. The question is again to draw the freeing the body or force body diagram. So block separate, spring separate. Everything is at rest. Okay, now here is the thing. What we are going to do is, first of all, so understand we are trying to build up the concepts of FBD. Once you learn FBD, trust me, you will be able to solve all kinds of questions. So the first part of today's session, or rather the first 1/3 part of the session is just FBDs, and slowly you will see some good problems as we go through it. Okay, so first thing, there will be a weight over here, so that is mg, and the spring is being stretched. It's being stretched, right? So what will it do? It will pull up the block. So there will be a spring force like this. There will be a spring force like this. It is at rest, A0. For this spring, understand, if I tell you who is applying the spring force, this is by the spring on the block. Understand, by Newton's third law, there should be a reaction of this force. Hence, on the spring by the block, there should be the same amount of force. So this is the reaction. So this is by the block. This is by the block on the spring. You don't have to write this every time. This is only in the initial stages for your understanding, nothing else. Thank you, Alia Bacha. Okay. Now, here is the thing. The spring is also at rest. If the spring is at rest, there must be one more force to balance it. Who will apply that force? From the top, from the roof, there will be one more force. I don't know, I'll just call the force from the roof. Force from the roof. Okay, it's fine. I mean, it's not a problem, not an issue. So, all these are the forces. Now, everything is at rest. Everything is at rest since everything is at equilibrium. Equilibrium, that means F from the roof should be equal to the spring force, which is also equal to mg. But do you remember what was spring force? It was K into X. It was tension. It's up to you. You can show it as tension. You can show it as force by the roof. It doesn't matter. Anyways, yes, in the spring's coil, there will be tension. In the spring's coil, there will be tension. You can say that there is a hook over there where the spring is being held and there will be a normal force from the top. I hope this is understood. Yes, so yes, there is tension in the spring, but you can also say that wherever the spring is attached, understand there might be a hook or something like that, and the spring might be attached. That surfaces are in contact, and that, you know, is being pulled by that force by the roof. That force by the roof could be anything. It could be tension, it could be anything, guys. Or you can also call it as the normal, depending on how it is attached to the roof, depending on that. Okay, now once this is understood, spring force is Kx, so Kx is equal to mg, x is equal to mg by k. So I have found out technically how much is the spring extended by. The spring has extended by mg by k to keep it in equilibrium. That's how it is. Okay, great. Let's get going to the next one. And by the way, let me also tell you, let's get going. Arul, mock test will start after the BITSAT is over, bacha. Okay, so hold on. This week is only for the BITSAT exam to get over. Once that is done, I'll obviously come to more mock tests. Okay, cool. Thank you, Alia bacha. Thank you so much. Thank you. Okay, so very good, Santharu. Don't worry, Santharu, for JEE 2022, our Pathfinder series are on. And Santharu, you can also check out my recorded classes of EMI. And next week, you will also see the continuation of those live classes on the chapter of electromagnetic induction of 12th standard. Okay, cool. Chalo, Siva, we are here. So why should I duplicate the same thing on 2 channels? No, that's why we are continuing the same thing. Whatever we are supposed to do, we are anyways doing it over here, rather than bifurcating and spreading our energies on 2 different channels. So understand, we are doing everything whatever we are supposed to on this channel. Okay, chalo. Thank you, Shubham Upadhyay. Okay, hi Jayasee, hello Yamla, hello Shirdi, hi Srija, welcome aboard, guys. Let's solve the next question coming up on your screen. And there are many things which I can break it up to. So very interesting free body diagram. Let's start doing this quickly. Okay, so let's say this is M1, let's say this is M2, let's say this is K1, let's say this is K2. Both different springs, different masses. So this is M1, this is K1, this is M2, this is K2. Okay, let's start from below because there are hardly any forces on M1. Slowly I can go up. So M1 will have M1G down and spring force Fs1 upwards. Because the spring is stretched, it will be pulling it. Spring block. Each spring is being pulled by different blocks. Okay, this Fs1 will have a reaction like this. Okay, this is action, this is reaction by Newton's third law. And over here, there will be another Fs1. Magnitude wise, they should be same. Else the spring will start accelerating up or down. So hence both of them should be equal, guys. No doubt about it. Okay. Now from this diagram, isn't it obvious, since acceleration is 0, Fs1 will be equal to m1g. Therefore K1 x1 will be equal to m1g. Therefore x1 will be equal to m1g by K1. So the lower spring has m1g by K1 as the extension. That's how I got it. Yes, you can also call it as tension. Spring force indirectly, Zayad, every time it will be tension, because at the end of the day it is a string, hard, a little bit stiff kind of a string which is wound. So indirectly it is tension only, if you think about it. Thank you, Riya Bacha. Okay. Now let's get going to the next part. See, who is applying this Fs1? Who is applying this Fs1? This M2. Look at this. This M2 is pulling this spring up. So if M2 pulls spring up, the spring will pull M2 down by the same force, Fs1. Correcto? So action, reaction. Next, this M2 will have its own weight. So I will call this as M2G, and the spring on the top will get pulled. So it will pull this M2 up. It will not like it going down, so it will pull this M2 up. So there will be Fs2. This Fs2 is being applied by the spring on the block. So the block on the spring will apply Fs2 down. Action, reaction. Eventually the spring is at rest. So if Fs2 is down, there must be an equal force Fs2 on the top. That's what it is. And all you need to do is that balance the forces, since acceleration is 0 on M2, Fs2, which is the force on the top, should be Fs1 plus M2g. But wait a minute, what is Fs1? It is M1g. So substitute it. So it will be M1g plus M2g. And what is spring force 2? Spring force is always Kx. So it is K into X. Why 2? Because it's a different spring, different extension. So X2 will be M1 plus M2 whole thing into G divided by K2. That's how I can find it out. Amazing. Understood? Hari, actually, lot of the there is not just one teacher, there are many teachers for me who have helped me during my coaching and who have helped me not just in coaching but also in school. I mean, I cannot say that this was the only teacher responsible. So many teachers have been responsible to make me who I am. So many mentors I found when I joined as a fresher, in coaching, and I'm so glad that so many teachers have helped me. It's not just one teacher. I'm really thankful to all my school teachers, all my coaching teachers, all my teachers who acted like mentors. Thank you to everyone, in fact. Okay, chalo, let's get going to the next one. So I'm pretty sure this must be fun, and let's go to the next one where you have a spring connected to a block lying on a floor which is at an inclined plane, which is like an inclined plane. Yes. So now what do you do? Let's see. This is angle theta. This is angle theta. Okay, let's see whether I have the slide for separating them out. Yes, I have it. Beautiful. So I just separate them out, and this is where many students find a difficulty. Sir, I don't understand which is cos, which is sine. Hold on, I'm teaching you a trick in a minute. Okay, so let's say this is theta. Let's say this is k. Let's say this is m. Let's see how do you find extensions, normals, and all the forces related information in this particular diagram. First of all, let's start with small m and see what kind of forces are acting on it. So number one is that there will be weight, that is mg, acting downwards. Do not say, sir, the block is tilted, so weight will act that way. Now, the center of the earth is still down, so the weight has to act downwards. Number one. Number two, the two surfaces are in contact like this. Whenever surfaces are in contact, normal means perpendicular. So perpendicular to the surfaces in contact. So if you draw perpendicular to the surfaces in contact, that should be this way. Hence, there must be a normal in this direction. I hope this is clear. Okay. Now, Thirumma, Vallham, nobody knows Bacha. If I knew, I would definitely tell you. In fact, I would declare that every student has got 100 percentile. Trust me, I don't know, man. I'm not in the government, okay? So I'm not a secret agent of the government who keeps telling me, hey, Shreyas, guess what? The result is going to be out at this time. I don't know. Okay. So, next thing, apart from this, is that, this spring is extended. Why is it extended? This block wants, feel what the block wants to do. It wants to go down. So what will the spring say? Hey, don't go down, come back, man. So the spring is extended. So if it is extended, so the spring will pull it upwards like this. So there is a spring force this way, the reaction of that on the spring. Action, reaction. That's how it works. And this wall will apply the same force like this over here. This is how the free body diagram looks like. Great. Now, okay, thank you. Okay, now what we need to do is this. I don't know who is what. What is the value of normal? What is the value of spring force? I don't know. Let's figure this out. All you need to do is, remember this rule, division by 8. What is it? What is the rule to figure out the angles? Division by 8. Divide into 8 parts. How 8 parts? Look at this. Horizontal, vertical, horizontal, vertical, perpendicular to incline, along the incline, Now do you see 1, 2, 3, 4, 5, 6, 7, 8? 8 parts being divided. So that's what I said, division by 8. That's what you need to do. Hello Farana, welcome aboard. Now, here is the thing. Badri, you don't have to purchase test series separately. Test series is a part of crash course, bacha. Now, here is the thing. This is theta, right? Come on, use your right hand or just think logically. If this is theta, just move this like this. Isn't this also theta? Check this out, what I just did. This is theta, correct? So even this is theta. So how about marking this as theta? If this is theta, now it's just alternate. It's just alternate, guys. If this is theta, this is 90 minus theta. If this is 90 minus theta, this is 90 minus 90 minus theta, which is theta. And if this is theta, then this is also theta. And if this is theta, again the alternate, this is also theta. Every alternate angle will become theta. Isn't this such a brilliant method? Now you know all the angles. Now you can split it up however you want it, guys. However you want it. This is best thing to do. Now, since it is at rest, how about this? How about splitting mg? How about splitting mg into two components? See, the one which is closer, close means pass in Hindi. Pass is rhyming with cos. Close, pass, cos. So the component which is closer, I will call it mg cos theta. Cos, closer. The other component, so this is mg, two components, split it into two components. The one which is far, you have gone far away, you have committed a sin, so sine. So this will be mg sine theta. I hope this is clear. Okay. Badri, it should be available. Still, if it is not available, just send a message to vcare@vedantu.com or send me a private message on Instagram. I'll definitely look into it. It should be available. Okay. Now, if this is mg sine, this is mg cos, all you need to do, think mg sine is balanced by fs. Interesting. fs is balancing mg sine theta, correct? And what is fs? fs is kx. So kx is mg sine theta. Therefore, x is equal to mg sine theta by k. I have found the extension, guys. Very interesting. Very good, Roshni. You remember the trick. Cos pass, sine away. Very good. Excellent. Now, you have found out extension. If somebody asks you, find normal, I'll be like, okay, big deal. Now I know normal is exactly opposite to mg cos, so they should balance. So normal will be equal to mg cos theta. So I have got both the things in case they were asked. I hope everybody is understanding this. Such a beautiful technique. You have learned the division by 8, and obviously I have just done a recap of cos and sine components. That's how you solve problems. So this is all building up the concepts for inclined plane, pulley, tension, spring questions. Let's do another question coming up on your screen. There is a sphere and it is stuck between a vertical wall and an inclined plane. It's stuck somewhere in between. Okay. Pradeep, trust me, you keep saying things again and again, discuss with others, watch classes, don't just read books, see somebody talking about it and teaching it, and say it again and again, write it again and again. Trust me, you'll remember it. Okay, there's nothing great about it. It's just like how you remember your name, because you know it so many times, you say it, you hear it, so that's why you remember your name. But you might not remember some random person's name, or you remember your best friend's name because you talk about him or talk about her in day-to-day life. So if you keep saying it again and again, keep hearing the same thing again and again, you will remember it, bacha. Okay. Hi Tushar, welcome aboard. Yes, tomorrow's class, Alia, will be on 2021 students, but for 11th standard students, the strategy session is coming up very soon. Just hold on for that. And also for 12th standard students. Okay. Thank you, top 5 uniques. Now, let's think what and all are the forces. Okay, this is theta, guys. Let's say the mass is m. Okay. Now, let's see what are the forces. Number 1, the own weight of the block, or sorry, not the block, the sphere, will be acting downwards. This is the sphere's own weight, and that would be mg. How many normals should I draw? Quickly let me know in the chat box. Think about it. Hi Prapti Bacha, little bit late, but come on, join in. Okay, committed sin versus committing warriors. Warriors always win, they don't commit sins. 2, very good Abhi. Ayush, $35 you want to invest, man? Very good, very good. You want to invest $35. So I will say, do one thing, invest 35 into 2, $70. Roughly the price of crash course. Roughly the price of crash course. So guys, very simple trick. Invest $70, 35 into 2, roughly the price of our crash course. Crack JEE, get into good college, spend 4 more years, get the best packages, and you will get lakhs of rupees packages. So that's how you convert $70 into lakhs of rupees. So I hope that is the best investment tip ever. Please use that. Okay, cool. Chalo. Now there are 2 normals. So first normal will be like this. First normal will be like this, N1. Second normal from here, like this. Notice one thing, I'm purposely showing all of them passing through the center. Purposely, I'm showing. Meghna, the question is to draw FBD and figure out all the unknowns out here. That's the question. Now, here is the thing, guys. Why are they all passing through the center? Very simple. This is tangent. This is tangent. Perpendicular to the tangent will always pass through the center, isn't it? Hence, that's why I'm showing it passing through the center. Now, again you can use my division by 8 rule. Let's do that. Look at this, guys. Vertical, horizontal, along perpendicular to the incline and along the incline. So these are all the different lines that I have drawn to make the division. Now if this is theta, clearly look at this. If this is theta, it's very obvious. This is also theta, this is also theta, and this is also theta, and this is also theta. Correcto? Correcto? Now think about it. In the vertical direction, separate, and in the horizontal direction separate. In the vertical direction, normal has 2 components. In vertical direction, normal has 1 component. In horizontal, it has the other component. What are the 2 components of normal? What is the upward component? Is it cos or sine? Look at this. This is a closer one. Close, cos, pass. So N1 cos, which is upwards, will be balanced by mg, which is downwards. So therefore N1 will be mg by cos theta. I got it. I hope this is clear. Great, great. Now here is the next thing. For N2, take the other component of N1. What is the other component? Horizontal. It will be sine component. So look at that. N1 sine theta, which will act right side, will be balanced by N2 towards left side. N1's sine balanced by M2. Mg has no role to play in the horizontal because it is vertical. Great. But what is the value of N1? I just got it. So therefore N2 will be mg by cos theta from here into sine theta. So therefore it is mg tan of theta. That's the value of N2. So I have found out both the normals in case they were asked in the question. So there is no unknown now. Yes, Shiva, projectile motion is already done, bacha. Rishabh, I remember you. All right, Marimal Devandran. Okay, Zayad. I hope you guys got this. Excellent day. Hi, Risky Warrior. Shwiz Bees. Yes, you are a little bit late, but join in. You will understand little bit at least. So later on, you can watch the replay of the missed part. Can we go ahead? Come on, guys. Let me know. Put some fire. Light the chat box with fire emojis. Like the chat box. Let's get going. If you guys have understood all these things. Very good, Suchi Mama. Excellent day. Kunlandai. Okay. Oh, this sum came in projectile motion. Oh, is it? Yes. Okay. But before we go ahead, let me tell you guys, if you have any doubt, doesn't matter. Okay. So if you study something and no matter which book you use, any doubt, you can ask via downloading our Doubt app. I mean, it's a part of Vedantu's app. There is a functionality, ask me anything. You can ask unlimited doubts from morning till night. And there is an expert sitting on the other side with whom you can chat, send screenshots. You can even ask for hints, not even complete solution. So that way you can proceed with the problem. Doesn't matter which book you're solving. So that is our doubt clearing facility available in the Vedantu app. Download the Vedantu app, which is very important, guys. And this is free of cost, unlimited doubts, no limitation on that if you're a part of the pro subscription. All right, I can see the fire and the stars. Very good. Thank you, guys. Okay, now let's start solving some good questions. Now that you are probably warmed up, you know how to solve and draw the FBDs. Let's do some good questions. Here is the first question. Look at this, guys. So there is a spring and it is compressed between two blocks and masses are given. There is a surface which is frictionless. Okay, the spring constant is 10 and initially they are compressed by 0.5 meters and released from rest. All right. So if you compress the spring, what will the spring do? If you're compressing the spring, it will push both the blocks out. If you compress the spring, you will, yes, see both the blocks will be pushed outwards, right? Great. So think about the free body diagram. Because it is compressed, this spring, if you draw the free body diagram, it will push it this way. The same spring is pushing the block the other way, the other block. So the same force will be applicable here. You might think, no sir, the blocks are different. How can Fs be same? Here is the logic behind it. See, if you draw the free body diagram of the spring, because it is compressed, the blocks are bringing them to closer. Spring force will act from here and from here, and both of them must be equal since it is at rest. So the forces from both sides should be equal. So the forces which the spring applies on both the blocks should also be equal. Okay. Now, Marcus, I'm not ignoring anyone, bacha. Concentrate. All right, Hemant, I will talk about the JEE results probably towards the end. Let's get going to the next one. Now, in this FBD, there will be also weight, which is M2G, normal, N2. There will be also weight, M1G, and there is another normal over here. But guys, will these normals and weights matter or will it not matter? Think about it. Think about it, guys. Will these weights matter or will it not matter? Think about it. I don't think it will matter, guys. Why won't it matter? Think about it. Why won't it matter? Why won't it matter? Because the motion is happening horizontally. Motion is happening horizontally. No, it's not like free fall. The motion is happening horizontally. Whatever happens in Y will affect only things in Y. Whatever happens in X will not affect things in X. Okay, so will not affect things in Y. So whatever happens in X will affect things in X. Whatever happens in Y will affect things in Y. That's the logic. So this block will have some acceleration. Let's say I call it A1. This block will also have some acceleration. Let's say I call it A2. So can I not say, guys, there is only one force on M1 and that is Fs. So Fs will be M1 A1. Now what is the value of Fs? It's Kx. What is K? What is K? K is 10 Newton per meter. Okay, 10 into what is X? X is 0.5. So 0.5. M1, what is the value of M1? It is nothing but 2 into A1. Everybody fine? So therefore A1 will be equal to 0.5 into 10, 5. 5 by 2. 5 by 2 meters per second square. So first block is accelerating left side with 5 by 2 meters per second square. Okay, great Radhika. I'm so happy that the results are announced, but I want to concentrate on the class. But congratulations, I'll talk more about it very soon. In fact, I'm conducting a special class tomorrow at 7:30 based on your result. Okay, so be there. Similarly, for the other block, the same spring force is mass into acceleration 2. What is the force? Again, K. What is K? 10. What is X? It is 0.5. is mass. What is the mass? It's 4 into A2. So therefore A2 will be 5 by 4 meters per second square. But that's not the question. Read the question carefully. The question is, what is the initial relative acceleration? Relative acceleration, guys. Quickly think and tell me the relative acceleration's magnitude. Will it be A1 plus A2 or A1 minus A2? Check the directions. Check the directions carefully. A1 is this side, A2 is that side. So will their relative acceleration add A1 and A2 or will I subtract? Think about it. Think about it. It will be adding. It will be adding plus. Correct, Karthi. Correct, Abhi. Very good. Excellent. So this block goes this way, that block goes this way. So you can see the relative will be more. Add this plus this will give me relative. So it will be 5 by 2 plus 5 by 4, which is 5 common, and you can write this as 2 by 4 plus 1 by 4, which is 5 into 3 by 4, which is 15 by 4, which is 3.75 meters per second square. That's the answer. Very good. Yes, Meghna, correct. They are opposite. So in fact, even if you go by, vectors, you will still get the same answer. A12 will be A1 minus A2, correct? So what is A1? A1 is 5 by 2. Okay, 5 by 2. Minus, what is A2? Negative direction of that. So minus of that. Because these directions are opposite. So you will see anyways it will become 5 by 2 plus 5 by 4. So they will add. Actually vector wise they subtract, but because of the direction minus minus becomes plus. I hope this is fine. Okay. Hello Pooja, welcome aboard. Very good, Zayed. Nice to know that the JEE Main's third attempt results are out. I'll be having a detailed lecture tomorrow. Congratulations to all those of you who got well. And those of you who did not score well, don't worry. I'm conducting a special session, strategy session for all of you. Okay, that's 3.75. Let's get going to the next question coming up on your screen. Okay. Now, here's the next question. The question is find the tension in the string AB. Let's see how many of you can quickly do this within 1 minute. If you guys have been understanding these questions, FBDs really well, you will get it. This is at rest. This is a knot. There is a force F. There is a mg. What is the tension over here in terms of F? That's the question. Let's see whether you can solve this in 1 minute. Come on, my warriors, you can do this. Come on, my warriors, you can do this for sure. Very easy question. Come on, my warriors. Joseph saying B, Meghna saying A, specific size saying C. Raghunatham, there will be more 2-3 lectures at least, man, because friction is there, pseudo force is there, constrained motion is there. It's a big chapter, so a lot of lectures coming up, okay? Plus advanced session, Menti session will be there. Okay, C, B, people are confused. Okay, so what you should do is draw the free body diagram of the knot. So my system is this knot, and the forces acting on it are, one is F of course, one is mg from below, and there is one tension over here. And if this is theta, it's very obvious, if I draw a line like this, this will be also theta. Now this tension will have two components, one will be here and the other will be here. The one which is horizontal, that will be T, it's far away, so T sine theta, and the one which is closer, that will be T cos theta. Now in the horizontal direction, okay, in the horizontal direction, here is what I can say. The force towards the right should be balanced by the force towards the left, and that's T sine theta. Therefore T will be F by sine theta, and that's the answer, and that's option B, guys. So all those of you said B are correct. Okay, yes, that's it, as simple as that. So that's the answer. No need of M in this question. In case the question was on vertical direction, then you would have said T cos theta will be mg. So you can find M from this if asked. but it was not us, so we are not bothered, but I just showed it to you. Okay, so that's B option. A lot of you got it correct. Beautiful, guys. Amazing. Go. Let's get going to the next question. Here is the next question. Very good, Joseph. I know you said it first. Find the normal force on the block. Find the normal force on the block. Also, how much time does it take to go down? This is height h. The inclination is theta. Obviously, to find forces and the time, I need acceleration. And if I need acceleration, I need to draw FBD, Newton's laws. So, let's start with free body diagram. What are the forces? Again, there will be mg down. Okay. There will be normal force like this. And eventually, this is going to accelerate. So, acceleration over here. That's it. Nothing apart from that. Nothing else. Now, I cannot find acceleration directly. I need to first resolve, as in split the forces. So, should I split normal or should I split mg? It's obvious that normal is perpendicular to the acceleration. There's no point. So, mg is at an angle with the acceleration. So, probably I need to split mg. Using my rule, which I just told you, along the incline, perpendicular to the incline, vertical and horizontal, division by 8. Quickly you will understand, if this is theta, obviously even this is theta. Look at this is theta. So just move your hands, you can see this is also theta. So this is also theta, this is also theta, and this is also theta. So this mg will have two components. You can get rid of mg and you can say this is closer, so mg cos theta. This is farther, so this is mg sin theta. Now I can think about vertical to the incline and along the incline. So perpendicular to the inclined plane. Perpendicular to the inclined plane. Look at this. Is there any acceleration? No, right? The acceleration only is like this. So along that direction there is no acceleration. So the normal force must be equal to mg cos theta. So that's my first answer. That's my first answer which I got. That was the first question. Find the normal force on the block. Second question. Let's see. Pooja Bacha, don't worry. Please stay with us. Don't worry. Just derive motivation from the classes. Enjoy the live classes. Keep solving. You will eventually crack JEE. Trust me on this. There is a lot of time. And just follow it systematically. That's all. Hard work, patience and faith. That's what you will need. Now, in this direction, the only force is mg sin theta. So, along the incline plane, the only force is mg sin theta. That will be equal to mass into acceleration. Mass into acceleration. Acceleration is not a force. It's just the effect of the force. Okay, so don't write mg sin theta plus ma. That's stupidity. Okay, now goes, therefore acceleration is g sin theta. Okay, great. But that's not the question. The question is how much time does it take? Oh, how do I find? Sir, that division by 8 method is confusing. Farhana, just watch my previous recording. I mean, just sometime back what I told you. So, vertical, horizontal, along the incline, perpendicular to the incline. Just draw these 8 lines, bacha, and just use your hands. See, this is theta, right? If this is theta, this is also going to be theta anyways. Or you can think this is also going to be theta. Because when you have two parallel lines, if this is theta, this is also theta. So that's why if this is theta, this is theta. Or you can also look at it like this. Both ways you will get theta. Okay. So with practice you will get it. Okay. Great. Now here is the thing. What is the length of this? If this length is L, do I know the length? Yes. Sin theta is h by L. Therefore, L will be h by sin theta. Now, why did I do this? Why did I do this? Because I'm going to apply second kinematic equation. S is ut plus half at square. Initial velocity 0. S is L. Acceleration from here. That's all you need to do. And let's see what do we get. What is the length? Length is h by sin theta. What is u? 0. Gone. Plus half into acceleration. What is it? G sin theta into t square. rearrange, you are going to get 2h by g sine square theta is equal to t square. From this, you're going to get t is equal to 1 by sine theta when I take the root, and root of 2h by g. That should be the answer. How many of you got it? Understood? Let me know. Let me know if you guys have understood it. Thank you, 𝐏𝐵𝐏𝐘𝐲. Whole right. So, Newton's laws, trigonometry, kinematics, vectors, resolution, and basic, common sense and algebra. That's it. So that's what you need for solving these questions. Okay. Let's get going to the next one coming up on your screen. How g sine square, sine into sine. Govindan, there were two signs. There was a sign below, there was a sign on the top. So when you shifted it, it became sine square. That's how it became sine square. Okay, there were two signs. Just replay it a little bit behind, you will see it. Okay, so that's the answer. Cool. So this is a beautiful simulation which shows different blocks coming down with different accelerations. Obviously, if the plane is inclined a lot, you will see the gravity's component will be larger. Gravitational component will be larger and it will accelerate very fast. But when the inclination is small, it will accelerate slowly. In fact, I had just shown you the acceleration was g sine theta. So if theta is more, acceleration is also more. That's it, as simple as that. So this is a simple way of looking at it. Theta is more, acceleration is more. Okay, so keep this in mind. A very beautiful simulation out here. Next question. This is just a 20-second question, but still I'll give you a time for 1 minute. Block 1, block 2, block 3, block 4, block 5, block n. N blocks are there. The force between n minus 1th, second last and the last block. So do you see there will be some normal force over here? Do you see that there will be some normal force between the last and the second last block? So the question is, what will be the value of that normal force? Let's see how many of you can solve this. Question is starting now. Very good, Yoganand. I know the JEE Main's results are out, and every time it happens during my class, and especially when I'm taking 11th or 12th class, some or the other result will be out, or somebody will come live, or some announcement is made. And then suddenly, students will start spamming the chat box. Okay, sir, the results are out, sir. This is done, sir. Very good. So, Yoganand, I'll see you guys tomorrow at 7:30, especially the 2021 students, on how to prepare for the last final attempt. That's the 4th attempt. Hi, Chaitla Bacha. Okay, so everybody is saying option A. Guys, everybody is saying option A. Is that true? Okay. Tati, Prajan, Meghna. All right, Joseph. Interesting, interesting. Answer is A. Yes, Pooja, this is a J channel and I'll cover all the concepts. But understand, Pooja, I might not teach everything in one lecture. I might spread it over the classes. I might teach some things in advanced classes. I might teach something in Menti quizzes. I might teach something in more revision classes. If I tell you everything in one lecture, your brain will get freezed. You will not understand it. So you have to go step by step. But yes, eventually I will teach you everything, whatever is required for JEE. Okay? Don't worry. Guys, I just told you about this, acceleration. It is g sine theta. That means it is not dependent. It's not dependent on mass. That means if I have a block, doesn't matter what the mass is, it will come down with g sine theta. If I have another block, doesn't matter what the mass is, even that block will come down with g sine theta. So if I ask you what is the relative acceleration, both are coming down with g sine theta. So the relative acceleration will be 0, right? The relative acceleration will be 0, right? Now if the relative acceleration is 0, think both are coming down simultaneously. The upper one is not pushing the lower one, nor are they separating out. So if both are coming together, there is no push or pull. This implies there is no push or pull between any of these blocks. So the question asks us, what is the force between these blocks? Since there is no push or pull, hence the answer is option B, which is 0. I hope this is clear. Yes, Zayad, your messages are visible. Hi, Achhe, Tej Verma. I hope you are very Achhe. Yes, the answer is B. Yep, lot of people make this mistake. They unnecessarily complicate the scenario. So the logic was, the acceleration is not dependent on the mass, like I showed you before, and hence all masses will accelerate simultaneously. Neither of them is pushing or pulling each other, and that's the reason why there is no relative acceleration, no push and pull. So there is no force of interaction between any of these blocks. All of them have 0, 0 force of interaction, as if all of them were falling down independently. Yes, that's the answer. Very good, Deepa. If you have told the answer, very good. Oof, oh, okay. Here is the next question coming up on your screen now. Beautiful question. Okay, thank you, Vempadu Babu. Pooja, I'm not sure. Probably you should check the schedule, bacha. I can probably tell you about physics classes, probably about chemistry. You should ask Wasim sir, or you should check the schedule. But usually they are at 10:30. Okay. Acha. Now find accelerations of the block. What is the tension in the string, etc., etc. Okay. Start with FBD. I'll tell you what is happening. There is a pulley. There is a string. It is going over that pulley. This block and this block, they will go up and down. So if you release it, let's just assume M1 is more than M2. So what will happen? M1 will go down with acceleration A. It will go down. It will pull the string. So M2 will go up by the same acceleration A. Isn't it? So guys, understand, when this block goes down, the other block goes up. If this goes by 1 centimeter, this will also go up by 1 centimeter. So both their accelerations are same in magnitude, but opposite in direction. Great. Now let's draw the free body diagram. The question is to find tension and the accelerations. So whose free body diagrams are you going to draw? Obviously M1 and M2. Let's do that. So over here, there will be a tension because string is being put on the pulley and it is being pulled down by the blocks. The string is pulled down by the blocks. So the blocks will be pulled up by the string. Look at this, get a feeling of it. The string is put on the pulley, the blocks are pulling the string down, both sides. So the blocks will be pulled up by the string. And since the string is the same, the tensions will be the same. String is same, tensions will be the same. I hope this is clear. Everybody fine till this point? Let's get going. Okay, now, 1 second guys. I just realized my AC temperature is set to really hot, so that's why I was sweating and it's throwing out hot air. Sorry guys. Yeah. Okay. Now, yeah, tension is up, great. So there will be M2G below and M1G below. For M1, who will be bigger, M1G or T? Check the direction of the acceleration. Where is it going? Down, right? So M1G is more than T. Hence, for M1, or else I'll put it over here. So for M1, and this is for M2. Okay, so for M1, M1G is more. So M1G minus T is equal to M1A. For M2, M2 is going up. So upward force will be bigger. So net force will be T minus M2G. That's the catch. Here it was M1G minus T because it was going down. Yes. So once you get this, you just write this as M2A. Now it's just a matter of solving these two equations. How do you solve this? Just add them. So add these two equations. So when you add these two equations, T and T will get cancelled. So you will have M1G minus M2G is equal to M1A plus M2A. Therefore, taking A common and bringing this down, I will have M1 minus M2, okay, into G divided by M1 plus M2 is equal to A. So that is my first answer. So acceleration of the blocks, yes, I have figured it out. Great. Next up, Next up, yes, unanimous, I know the results have been declared or whatever, but concentrate on the session because this is 11th standard class. Next up is finding the tension. How do you find the tension? Take this acceleration and put it over here. Just take the acceleration and put it over here, you will get it. So this will become m1g minus t is equal to m1 into a, which is m1 minus m2 into g upon m1 plus m2. Okay, take this guy over here, take the tension on the right side. So it will become m1 g is common, 1 minus, okay, m1 minus m2 upon m1 plus m2. Okay, tension has been taken to the other side. This whole big term has been taken to the left. m1g and m1g is taken common. Therefore, m1g into, this is in the denominator, take LCM. So m1 plus m2 minus m1 plus m2, the whole thing is equal to t. This is divided by m1 plus m2, of course. You can clearly see over here that m1 and m1 will get cancelled. m2 and m2 will become 2m2. So therefore, I'll get 2m1 m2 into g divided by m1 plus m2 is equal to tension. So that is the tension, of course. So that is the tension. I hope this is fine. Yes, 2m1 m2 upon m1 plus m2, okay, the whole thing into g. So it's better if you remember this, because this system, which is called as the 8-wood machine, one which goes up. So you take this block up, this goes down, you leave it, it will come down. So it's called as the 8-wood machine, the simple machine of pulleys and blocks. Great, let's get going. I'll talk about opening up method later on, bacha, but first let's understand the basic methods first. Okay, cool. Now let's do another question. Yeah, those were the answers like I told you. Now the same question, Joseph, I don't know Telugu, bacha. The same question, the question is, if the entire thing is being held by a spring balance, what is the reading shown? What is the reading shown by the spring balance? These kind of questions are also common. You're holding the pulley. Trust me, it is very easy. How? Draw the free body diagram of the pulley. Draw the free body diagram of the pulley. Spring will be pulling it up by a spring force. Because the spring is getting extended, it will pull the pulley up, correct? Upwards. Because there is a string wrapped over the pulley, the string is pulling the pulley down from both sides. So the string from here and here is applying tension and tension. Is that right? Now, no, it's not zero. A lot of people think it is zero. No. Now the pulley is at rest. The pulley is at rest. My system is the pulley, understand? So for that pulley, can I not say that the upward force, the spring force, is tension plus tension which is acting down? Because it is at rest, right? So hence spring force will be equal to 2t. But did I not just find out the value of t, guys? In the previous question, did I not just find out the value of p? Is that clear? So guys, just figure this out. Just figure this out. Just figure this out. What are you going to do? Just put 2 m1 m2 divided by m1 plus m2, the whole, oh by the way, there was g also, yeah, g, and that's it. So hence it is 4 m1 m2 upon m1 plus m2 into g. So that is the spring force. The spring force will be the reading shown, the reading in newtons, the reading in newtons. But if the spring balance reading is asked in kilograms, ignore the g. So the reading in kg, if that is the question, then just forget that g. Remember, the reading will be 4 m1 m2 by m1 plus m2 in kg. So that's the difference. Check the options. According to the options, you will mark the correct one. Okay, I hope this is clear. Very good. Hello Vaishali, join in bachalo. Very good. Chalo, let's get going to the next question coming up on your screen. And there it comes. Okay, yes, that's the answer. This is the incline. this is inclined, and again same thing. Now it is inclined, find the acceleration, find the tension and all those things. So all you need to do, I'll just help you with the free body diagram. I want you guys to try it out. Just I'll write down the equations, but you have to try it out at your home, and you have to figure out the acceleration, because only then you will get a hang of it. I'm showing you the solution so that you know whether you are in the right track or not. Okay, so this is 30. All right, let's start with the free body diagram, guys. This mass will have its weight mg down. This will have tension upwards, and this is heavier, so probably it will be going down like this. So if it goes down, it will pull the string. The string will get pulled up. This block will go up via acceleration A. Okay, cool. Next, there will be a normal force over here. The string will be pulling the block backwards. Remember, strings always pull. So tension over here. There will be 3 mg down. There will be 3 mg down. But using my splitting method, you can easily figure out what are the components. And by now you should know it, guys. If mg is down, this one will be 3 mg cos theta, and this one will be 3 mg sin theta. Sin theta is 30 basically. Correct. So all you need to do is write down the equations for each one of them. I'll just show you the equations. Solving part, you have to do it on your own, guys. So for this mass, it's going up, so net force is up, so tension is more. So tension minus mg is ma. That's one equation. For 3m mass, it's going down. Who is there? 3 mg sine is there, and tension is also there. This will be more, that will be less, that's why it's going down. So for 3m mass, I'll write 3 mg sine theta is sine 30, minus tension is equal to 3ma. So that's it. Solving this, you will get acceleration and tension like before. Try it out, guys. Okay, I hope this is clear. Venki Gamer, there is going to be a special class only on pseudo force and non-inertial frame. Okay, don't worry. Hi Surya Vachal, joining in late, I guess. Okay, cool. You'll be able to do it? Yes. So let's get going. Hi Lakshant. Yep, let's get going. I have two more questions, I guess. I want to do that, because if I don't do that, then you will face a lot of difficulties in these kind of questions. Get ready, guys. Come on, show some Josh out there. Okay, very good, Zayed. You're saying that you will be able to do it. Stravana Bacha, I will conduct backlog session. Don't worry about it, but give us some time. It will take some time, because, you know, first I want you to concentrate on it. Current topic. Sarvana, second thing, my previous class lectures are available. I will bring practice sessions for the previous chapters, but there is no point completing the chapter in one shot, bacha. You will not understand. Stravana, tell me one thing. Do you have to give the exam tomorrow? No, right? There is still a lot of time. So do you want to learn things haphazardly? Lot of things skipped within few hours, or you want to learn properly and not face difficulty later on? You decide and tell me. If you want half-baked knowledge, I don't mind conducting one shots, but I am thinking about you. That's why I'm not conducting one shot. I understand the reason. Okay, chalo. Here is the next question. The question is, find the tension as a function of x, or find the tension in the string. Basically, there is a mass m which is hanging over here. Length L is also given. Okay. Yes, correct, Siva. One shot is trash for beginning. Correct. Always go to the recorded classes. You have time. Please watch it. Okay. Please do that. Okay. Cool. No, don't be sorry, Shravana. It's my duty as a teacher to tell you what is correct and what is wrong. Okay, because or else what will happen after 6 months, you will come back and tell, sir, I don't understand electrostatics. I don't want you to be in that situation. That's why I care about you. That's all. Okay. Now, first of all, think and tell me, if this rope has mass, will the tension be same everywhere? Or do you think it will change as you go up or as you go down? Think carefully. Is the tension going to change or will it be constant? To understand that, think this way. Imagine there is a Pandu, okay, and he is holding somebody else's legs. He is holding somebody else's legs, and he is holding somebody else's legs, and he is holding the roof maybe. Pandu 1, 2, 3, 4. Which Pandu will feel lot of pain? Which Pandu will feel lot of pain? Think about it. 𝐊𝐕𝐏𝐾 guy, I'm already on pro in micro courses, but I'll be coming up with more micro courses in a month. Yeah, I know many of you are waiting for it. Yes. So, yes, Pandu 1 or Pandu 4. Pandu 1 will be feeling the least of it because Pandu 1 is holding Pandu 2. He's pulling Pandu 2 down. Pandu 2 is pulling Pandu 3 down. Pandu 3 is pulling Pandu 4 down. Pandu 4 has to bear all the weight of these 3 idiots down there. So Pandu 4 will face lot of tension, Pandu 3 less, Pandu 2 even less, Pandu 1 is the least. Same logic is applicable here. So think, where would the tension be highest? Because the point over here has to hold the entire weight. The point somewhere below has to hold only less weight below it. Hence, the tension will change. Yes. So what I will do is choose a system. Remember, I was talking about choice of system. Now you will see why it's very important to choose a system very wisely. I will choose this system. This is my system, guys. Let's just say this one, okay, is X. Let's say this is X. That's what is given. Okay. Okay. This is X. On this system, what and all are the forces? Obviously, the system will have some weight. So obviously there will be weight downwards. So weight downwards, and there will be tension upwards, and this is not going up or down. So acceleration is 0. It's at rest. Hence, the tension should be equal to the weight. Now comes the question. What is the weight? Most of you will jump and tell, sir, it is mg. Wrong, it is not mg. That's the problem. That's the problem. The problem is the weight is not mg because m is the total mass of the string. That is the problem. So the weight is not mg. So what do? Unitary method. Unitary method, like shopkeepers. This is also called shopkeeper method. If you go to a kirana store, a grocery store, for 2 biscuits, you pay 30 rupees. For 4 biscuits, you obviously pay 60 rupees. That's it. Proportional. Same way, for total length L, the mass is m. So for x length, how much is the mass? That how much will be m mass per unit length into the length. Is that true? Yes. Weight is mg, but that m is the mass of this part. This is my system, Zayed. Understand, this is my system. This is not my entire system. That's the catch. So that's all you need to do. Mass per unit length into the length will give you only the mass of this much part. Now you use this. The weight will be m by L x into g, and that is my answer. That's it. So this is the answer. Is that clear, guys? Understood? Hi Velaga. Understood? Clear? Clear? So unitary method. Total length L, mass m. A part of it, x, m by L into x. As simple as that. Very good. Very good, Babu. Very good. Good evening, Satish Vlogs. And there we go to the last question of today's session, and it's going to be an amazing one. It's going to be an amazing one. Here's the last question. I'll give you the homework questions also. Quickly, guys. This is a rope which is horizontal. Right side 2F, left side F. Question is find the tension. You'll be like, sir, won't the tension be same? No. Why? Because left side F, right side 2F. Oh, that's the catch. Is the rope going to be at rest? No. Why is it not going to be at rest? Right side more force, left side less force. Hence, it will accelerate. Which side will it accelerate? Towards the larger force. So there will be acceleration. There will be acceleration. Choose a system. I will choose the entire thing as a system. Why? I want to find acceleration. Tension is internal. I don't care about the tension. So the moment I choose the entire thing as a system, what will I get? The moment I choose the entire thing as a system, net force 2F minus F is equal to total mass into acceleration. Therefore, acceleration is F by m. That's what I got. Acceleration is F by m. Now, what do we do next? Once I got acceleration, the question is find the tension, guys. Tension will change. Believe me, tension will change. Choose a small system. That's why I told you, choice of system, very important. And let's just say this much is x. This x will have a mass of how much? I just told you. The total length L has mass m. X length has how much mass? Unitary method. It is m by L into x. So this much length has this much mass. That's it. Now, for this, draw the free body diagram. One side, there is F force. Other side, there is tension force. That's it, nothing else. And this guy is accelerating. So, I will say tension, bigger force, minus smaller force, is this guy's mass. What is it? It is mx by L into A. mx by L is the mass into acceleration, mass of this part. This is my system. I can choose anything as my system. I'm choosing this because it is convenient. I want to find tension at any point x. That's why I have made this tension external force by choosing a small part of the string as the system. Now guys, what am I going to do? T is equal to F plus mx by L into A. What is A? A is F by m. Interesting, oh? mm goes. And I get F common. So tension is F common 1 plus x by L. So do you see? Tension is a function of x. It changes with x. That's the beauty of this problem. How many of you got it? How many of you understood this? Such an amazing problem. Newton's laws, tension, choice of system, everything FBD in this question, guys. Beautiful question. I hope you enjoyed this. I'm going to give you your homework questions. That's the answer, by the way. This is your first question. This is your first question. Post up all your answers in the comment section below. We'll be checking who and all have commented in the next class. This is second question. Tensions have to be figured out. Okay, these are the tensions which have to be figured out in the strings which are hanging from the masses. This is the third question. Okay, person trying to climb up a rope. 3 questions as homework. You will be able to see these answers in the PDF later on. You can also replay back this session to take a screenshot and solve the problems. Remember one thing, the crash course is there available for 2021 students, but for you guys, if you want to learn under teachers like me, that too in English medium, that too in a long-term batch, also simultaneously prepare for KVPY like exams and want to take my micro courses, I have conducted HC Verma, Erudov, derivation, numerical problem solving for JEE and NEET, both. All these problem solving sessions, all my micro courses and so many other courses by so many other teachers. Trust me guys, I'm telling this from my heart. You need to boost your performance by the pro subscription. It's like Netflix. You take the subscription, everything is available. Notes, PDFs, your assignments, your modules, doubt solving, all right, test series, ranking, parent-teacher meetings, and all of this is there. You might think online education will not have parent-teacher meet. No, trust me, you're wrong, we have. Okay, now these courses start for as low as 2,700 rupees. That's the light version. When you use my coupon code SHHPRO, you get 10% off. That's a big amount. And let me tell you, you can buy for all 12 months. You can also pay EMI. So the price almost comes out to be 2,700 per month. 0% interest rates are available. These versions have extra features like doubt solving on the app and a personal mentor. But apart from that, everything else is same. The batches are starting on 16th of August. So do not delay your decision. And if you want to know more, please let me know on my Instagram handle, that's Shreyas_Vedantu. I hope you guys had an amazing time. See you guys next week. We'll continue the nurture series, lesson number 3 of Newton's laws. Do not forget to post the answers in the comment section. Do not forget to smash the like button and hit the subscribe button. That's it from my side. This was Shreyas here. Hasta la vista. Take care.